G'day, I'm Kyle from APT Training, and I'm here to talk about hoses, hose installation, and a few things to be mindful of when you are using hoses on site or doing a repair or anything like that. So hoses come in many different types and sizes, and I've got a few laid out here. They can small up into some bigger hoses, and certainly into some much larger hoses. Our ends can be crimped on, they can be push on, and all of these are suitable for some hydraulic systems. It's fairly important to note that not all hoses are the same, and it might be easy to get into the trap of just grabbing a hose just because that's the hose that's on site, that's what we've got. It's really important to actually check. We did have a story of a site that was installing hoses. They came straight off their rack, they've been hanging on the rack like this. They had a tag on them. The tag said that they were a 350 bar hose. Inside that sleeve there, you could not see the hose rating on it at all. And what it turned out to be was, instead of being a 2-wire braid, it was a single wire braid. Instead of having a 350 bar rating, it only had a 125 bar rating. Now the tag was tagged. There was obviously a failure, but you do still need to be responsible and check it all yourself. So hoses are not just hoses. It's really important that we actually check pressure rating as one of the first things that we do before we install a hose. So on the sheath of the hose itself, you should be able to read the pressure rating on the hose itself. Now, with a hose that is sleeved with the DAS sleeving or tech sleeve, whatever you want to call it, it should have a tag on there to say what the pressure rating is of the hose, and if it's being tested, it should tell you what the test pressure has been. So that's probably one of the first and most important things to check on a hose. Now, hose construction, if we quickly talk about hose construction, we talk about wire braid, or how many layers of wire. If you look deep down inside our hose here, and I can put it right up to the camera like this, you'll see that there's multiple layers. So we start on the inside here, we've got the tubing inside there, which is a smooth tube that allows the fluid to flow through it. Then we've got a layer of wire, so this is our wire braid. And then we've got some more rubber, another layer of wire, and another layer of rubber, or the sheathing that we talk about on the outside there. So 2-wire braid, could be 3, could be 4, maybe even more, depending on site. Typically, 2-wire braid on a lot of our systems is about right. In this particular size, it's 4,000 psi rating. Still need to check the pressure rating on the side of the hose though. So that's how our hoses are constructed. If you work in mining or construction, maybe, either here in Australia or often around the world, you might hear of MDG 41. So MDG 41 in New South Wales is Mechanical Design Guideline, or Mine Design Guideline 41, which is fluid power systems for use on site. The guideline is meant to be a collective wisdom helping people manage fluid power systems on site. It's pretty important to note that while it does get audited as an auditable document, it's not intended to be an auditable document. It's intended to be a list of recommendations for sites to use in managing fluid power systems, and obviously the associated components. Hoses fall into it, and the history of MDG 41 was there was some issues with hoses way back when MDG 41 started, and so that was one of the big focuses on getting consistency in hoses and what could be done to protect people from hose failures. Now, first line of defence is maintaining our hoses. So MDG 41 has all these great recommendations, but the first line of defence is actually maintaining and looking after our hoses. So getting to them before they fail, installing them properly, making sure that they're not going to be rubbing, wearing, and then if they are, that we're replacing them before they fail. We'll talk a little bit later about how to check and look after our hoses and when hoses probably should be changed. So when we talk about sleeving in regards to MDG 41, okay, so this hose here has a sleeving on it, as opposed to this one which has no sleeving on it. It's the thing that we need to remember is that that sleeving is PPE for the hose, or for the people around the hose, okay? It is the last line of defence. It's only a recommendation in MDG 41. It doesn't have to be there. And MDG 41 says that it should be used by risk assessment in high risk areas, so near where people, operators or maintainers might be while the system is pressurised or working. The DAS sleeve should redirect any flow or pinhole jets that come out of the hose due to a failure. So it's important that that DAS sleeve is actually loose to some extent. It shouldn't be tight against the hose itself. And if there is a failure inside that hose there, what will happen is that the jet will come out and be dispersed. The energy will be diffused by that sleeve. So it's not armour. It's not there to completely protect you from it. It's only there to diffuse anything if it does occur inside there. If you've got your hand on there, you may not necessarily be protected by that DAS sleeve. So it's an important thing to note is that you should not be having your hands on hoses while they are pressurised or working in a system. So it is a PPE, it is our final line of defence. Other things that are specified in MDG 41, our hoses should be tagged. Now on that tag it should have a traceable number so that the batch can be found or the build serial can be found. It should have on it the working pressure, the end types on it, and if it's been tested, the test date that it was tested. Okay. MDG 41 talks about testing the 2 times working pressure, so it would say that this particular hose has a assembly date of May 2017. There's a 400 bar rating, so it should have been tested to about 800 bar. Often done as a batch, so to speak. If that tag's not fitted, we should not be using those hoses because we cannot see what the pressure rating is or what the end types are, and let alone know the age of that hose. So again, MDG 41 recommends a limited shelf life, so we need to know when that was assembled, and so we know based on our site whether we should use it or not. That should be in your site's fluid power management plan, and you should understand that too. Next things to check when we're installing a hose would be the hose ends, or the types of the hose ends. So it's really easy to take, if we're really experienced on a site, and look at a bunch of hose fittings and think that we know exactly what it is. There's 3 hose fittings, hose ends, hose tails. All 3 of them are different. They're different threads and different conical shapes inside there, or sealing types on the inside. So they are not compatible with each other. They may screw together, they may seal if we tighten them up enough, but eventually they will fail. So it's important to make sure that we understand what that hose end is before we install it. You may actually need to refer to your hose guide or your fittings guide. So this is a Pertec one. Inside there is all the tools that you need and the information you need to be able to check what type of hose it actually is. So that's what we need to check on our hoses, that we've got the right hose ends, we've got the right pressure rating, and then we need to think about, is the fluid compatible with it? Now most of our systems will use mineral-based fluids, and normal everyday hydraulic hoses are suitable. If you use a high temperature system, which has glycol phosphate ester in it, the normal hoses will not be suitable. Equally, if your system is outside in the sun or close to something hot, such as an engine bay or a furnace, then the hose will need to be different to handle the higher temperatures. So UV and temperature affects our hose compatibility just as much as internally the fluid compatibility. So it's important to check all of those things as well. When we remove a hose to replace it, really important that we isolate, shut down and isolate correctly, dissipate any stored energy, and confirm that that's happened. Now all of our sites should have an isolation procedure for each of our machines, and so that should be able to work through, and you should be 100% confident that that is shut down and dissipated. If you're not 100% confident, then you need to get some help with it. Don't just assume that it'll be okay. So once we've taken our hose off to install the new one, we firstly need to check that we have the correct length. Now, too short a hose won't necessarily go in, so you won't be able to do it up. Or if you stretch it into place, what you'll do is you'll overstress that hose. It's not made to be stretched like that, and when the hose is pressurized, it expands this way, and therefore it gets shorter this way. So it's going to add extra stress onto that hose, and it will eventually fail. So we should not stretch them into place. Now, equally, we should also not use a hose that's too long and then twist it into a funky shape, because that's not going to be good for our hose, and we're probably exceeding the bend radius. So that moves us to our next point, that when we install a hose and we put it into a machine, that we're not exceeding the bend radius on all of our hoses. Okay, so our hose manufacturer will tell us what the minimum bend radius is, and you can feel it in the hose. If you don't have that information right in front of you, if you've got to push really, really hard on that hose to get it into a position, chances are you're exceeding the bend radius. Now, this is a fairly flexible hose, it'll bend a fair way, whereas this big heavy hose, I've got to work really, really hard to bend it into shape. So if I've got to put excess force on there to make it go into place, chances are I'm exceeding the bend radius of that particular hose. When we're looking at where we're attaching the hose, it's important that we check the fittings that we're connecting to, or the connections that we're connecting onto. This is a fitting here. This one's been welded together. Now that is not suitable, okay? You can see that there's some porosity in the weld. It's a fitting that's broken and then been welded back together. That's a problem waiting to happen. Equally, another one that came off a forklift. Okay, this one's bent. You can see the shape of it there. So it's bent. That one is eventually going to fail as well. So it's equally important that while we're checking our hoses, we also check our fittings to make sure that they're suitable and not damaged before we install them. Before we connect the hose up, you want to make sure that the fittings are clean, the hose ends are clean, and ideally our hoses, when they were manufactured, have been blown out or had the pellet go through them to make sure that they are clean internally as well. If that hose has been in the mud, down on the ground, because it's been dropped or not cared for, we probably want to put some effort into cleaning it first. Any contamination in our hydraulic systems is going to affect the performance of the hydraulic system, is going to increase wear, but most importantly, could create a safety problem due to stopping a valve from doing its job or stopping a function from working properly. So it's not only a wear or a maintenance issue, it could be a safety problem if we're not putting clean components into our hydraulic systems. Once we install our hose and we connect it in, it's important to make sure firstly that our bend radius is okay, but then secondly that it is run in a place where it's not going to be damaged, so it's not going to get an external impact, it's not going to have wear on it, so we're not going to have things rubbing on it, it's not going to accumulate mud, dirt and other contamination. And then also we want to check that we don't have any twists in the hose. So what I mean by that is when we install the hose, we should use 2 spanners on the hose end. We should use one on the hose itself and one on the fitting, and then do it up so that the hose doesn't twist. Now if we put a twist into our hose, what happens is that it overstresses every time that it moves. It's trying to break itself every time we pressurize. It's twisting and trying to tear itself apart. Anecdotal evidence suggests that by putting a 5-degree twist in our hose, so not much, just a little bit of a twist in our hoses, can lead to that hose failing in 1/10 of the time it should have. That's pretty short, okay? A significant impact on the life of that hose. For our hoses, and when we inspect our hoses, firstly we want to check that there's no excess damage to, if there's sheathing on it, that external sheathing or guarding. We want to make sure that there's no excess corrosion around the fittings, they're not bent, they're not damaged around there. On hoses that don't have the sheathing on them, or the sleeve, we want to be inspecting the cover of the hose itself. Now, this is probably the one area where hoses will wear and where we'll see a lot of damage on our hoses. So let's have a look at what might be an appropriate level. We should have no damage. Now that outer sheath, what it does is it protects the wires from corrosion, make sure that you're not going to get water, mud, dirt, all of that sort of stuff into the wires, because the wires are what provide the strength in our hoses. This particular hose here has some wear to the sheath there, and you can see that wear there pretty easily. When we see this sort of wear on it, as I look closely, there's no damage to any wires in there. I can run my finger over it. I wouldn't recommend that at home. There's no wires broken, and there's no physical or visible corrosion of those wires. Technically that hose is still intact, it's still doing its job. Now the downside is, eventually that's going to corrode, and that's going to fail at that point. That hose still needs to be changed. It still needs to be changed relatively soon, but it's not necessarily urgent, so to speak. Now, the next level is if we have any broken wires in there, or if we have corrosion of those wires. Now, I spoke before about a single wire hose having a pressure rating of, let's say, 350 bar, and a single wire hose having a pressure rating of 170 bar. Now, the reason for that is the layers of wire, the wire braid. As soon as we start to break the wires there, we lose that strength. Effectively, in that point there, we're halving, or even less, the pressure rating of the hose there. That means that we're at risk straight away. So if you've got broken wires, that hose really urgently needs to be changed, and in accordance with your site procedures, probably very, very soon. Now then, obviously any hose that's leaking needs to be changed straight away. Hoses can't be repaired with duct tape, electrical tape, a glove, splicing tape, rubber splicing tape. All of those things do not repair the hose. Once it has failed, it's failed because of that wire braid there. There's a failure all the way through. We cannot repair it in situ. It needs to be replaced. Any leaking hose needs to be replaced before someone gets hurt. The final thing that I wanted to talk about is staple fittings. So on here, I've got staple fittings. These are used in areas where lots and lots of hoses and connections need to be made in a compact area. There's only a staple that holds them in. A couple of tricks with these particular things. Firstly, the staples themselves are a single-use item. They should only be used once. Once it's been put into the hose and it comes out, get rid of them, get a new one. They do fatigue, they do wear where the hose holds them, and there's a lot of load on these particular pieces of equipment. So, single-use item are the staples. It's important that the staple is installed correctly. So this particular one is not installed all the way through the hose end. So this is likely to vibrate out. It's possible that it hasn't fully engaged on the hose and the tail itself, and therefore we've lost the strength in it. In an area where we install them, it's ideal to have them mounted so that the staple is up on top. So not upside down, where gravity is going to try and force that staple to fall out. If that's the case, we need to put a secondary retainer on to ensure that that staple stays in place. Finally, we can't substitute staples. Good old hose clip is not suitable for holding our staples together, even though it may look like it does the job. And then lastly, we shouldn't use our staples to hang other things on. So it might be a convenient spot to hang some gloves, some tools, some spare parts off those. It's a nice little hook there, but that's trying to pull that out. As soon as that staple comes out, we have no retaining there to hold that hose in place. So just a quick recap. Not all hoses are created equal. They're all a little bit different, whether that be single wire, multi-wire, whether that be push lock fittings, whether that be cringe fittings. And hose sleeving is really a PPE. It's our last line of defence. We shouldn't be relying on it to protect ourselves from high pressure. When we install hoses, we need to consider the hose ends, the pressure rating of the hose, make sure that we do know that. Compatibility with fluids and compatibility with our environment. So really important that we check all of those things. Not all fittings will go together, and some fittings will go together even though they're not compatible, so we have to ensure that they are the correct hose fittings. And lastly, inspect our hoses, make sure that we are checking them. Hoses that have sleeve on them, do not use your hands on them while they are pressurised to check and inspect them. The system should be depressurised if you're going to use your hand to feel for any damage in there. So check for external damage. If there's any wires broken, that hose is broken itself and you need to replace it pretty urgently. This is a quick rundown on hose installation. If you've got any questions, shoot us a message or most certainly get in touch with your site supervisor and ask them about your site's procedures.